Example 2, we're going to factor these quadratics. Whenever we factor quadratics, first of all, we look for the leading coefficient. In this case, there's no leading coefficient in A. And if there is a leading coefficient, we look to see if there's a greatest common factor. So in this case, there's neither. So we're going to look for two numbers that multiply to the last number of negative 63 and have a difference of negative 2. So there's not too many factors of 63. It's going to be 9 times 7. And those have a difference of 2. So we can write this as x minus 9 and then x plus 7. Because remember that these have to add to negative 2. So we're not going to make it equal to anything. This is all it is. We're going to leave it in factored form because the saying to factor, we're not solving for anything here. So for B, we have a leading coefficient, so that's important to note. We have this leading coefficient of 2. There's no common factors, so we can't factor that out. So the first thing that we're going to do is multiply the first times the last. So we're going to get the 6. And the reason why we're doing that is because we're going to take advantage of this diagonal product in our square, in our rectangle, where the diagonal product of the 2x squared times 3, that diagonal product of 6x squared has to be equal to the other diagonal, which gives us the middle term 7. So two numbers that multiply to 6 and add to 7 are going to be 1 and 6. So we get 6x, 1x, and we can factor the common factor. So the common factor through here is 2x. Through here, there's no common factor, so it's just going to be plus 1. Through here, the common factor is just x. And then the common factor through here is going to be 3. So we're going to end up with plus 3. So there is my factored form. Two numbers that multiply to 6 and add to 7 give us the factored form of 2x plus 1, x plus 3. Again, there's no equal to anything. We're not going to solve for x or anything like that. We're just going to leave it in factored form. For example 3, we want to write these entire radicals for these expressions. So entire radicals means we need to put the number inside. So going inside, we square. Taking it outside, we square root. So we can express the 2. This 2 can be expressed as 4 square root times 3 times root 3. Root and root, they go together, so we can just write this as square root 12. Okay, and you can skip this middle step if you like. Okay, same thing here. We have this term on the outside. We can square that, so we get 4a squared b6 when we square that, and that ends up in the square root. That's the same thing. And then we have 3a cubed b squared. Once we have it all under one root, both under the roots, we can just put this all together. So numbers times numbers, a's times a's, b's times b's. And so we get a5, b8.